For decades, weigh and motion systems have been some of the most powerful instruments to protect roads against overloaded vehicles, trucks especially. Many companies come to the market with different technologies for low speed and even high speed measurement, with the accuracy floating from 20% to the highest possible level of 5%. The systems enable many applications for statistical purposes, such as pre-selection with an active assistance of the police. And finally, some countries have even implemented legislation for direct enforcement. That all sounds great if the systems could make valid measurements across the whole width of the roadway. The limitations of current weigh and motion units. Despite their indisputable advantages, the current most widespread sensors used for dynamic weight measurement of vehicles in motion suffer from various limitations. The first examples of constraints consist of maneuvers during dynamic weighing. In most cases, the sensors are arranged in 2 or more rows, which allows repeating the measurements for higher accuracy. However, the sensors require the vehicle to move straight. As soon as the vehicle moves in a skewed direction, it is not possible to perform accurate measurements. Another limitation is the inaccuracy at the edges of the sensors. This limitation reflects the design and location of the sensor itself. The sensors are positioned horizontally in each lane. However, they are not equally distributed in the full width of the lane. While the measurement is the most accurate at the center of the track, it is not sufficient on the ends of sensors. If the vehicle moves between 2 lanes or at a lane side, the measurement is not reliable. This, of course, creates an opportunity for dishonest drivers to avoid weighing and subsequent fines. Weigh and motion, and the reduction of maintenance and repair costs with toll per ton. With the aim to capture and to record the axle and gross weights of vehicles, the weigh and motion units represent the most up-to-date solutions for traffic flow monitoring and regulation on the busiest communications. This automated system helps to detect the load violations, to save the human resources as well as the time needed for resolution, and of course, decrease the funds spent on the manual procedure and the road maintenance costs. One of its biggest contributions is the opportunity to create the system of paying tolls per weight. With the concept of toll per ton, each vehicle would pay exactly per each ton of its load, which would make current conditions much fairer, more transparent, and eventually, it might lead to the reduction of overloaded trucks. As the volume of transportation has been extending in recent years, all types of roads have been dealing with the never-ending influx of vehicles that tend to violate certain rules for the sake of saving resources. One of the most severe violations is exceeding the load's weight limit that leads to road impairment, causing additional burdens for maintenance and, therefore, a constant increase in repair costs. From a huge part, the expenditures are covered by toll fees. With the aim to assess and to record the axle and gross weight of vehicles, the weigh and motion units represent the most up-to-date solutions for traffic flow monitoring and regulation on the busiest roads. This automated system helps to detect the load violations, to save human resources, as well as the time needed for resolution, and of course, decrease the funds spent on the manual procedure and the road maintenance costs. One of its biggest contributions is the opportunity to create the system of paying tolls per weight. With the concept of toll per ton, each vehicle would pay exactly per each ton of its load, which would make current conditions much fairer, more transparent, and eventually, it might lead to the reduction of overloaded trucks. But these visions have significant requirements to be able to make the measurements in real free flow of passing vehicles, and to increase the accuracy into a 3 level according to WIM standards, which means 3% of gross vehicle weight.